Hello and welcome to chapter 43 of this Flutter course. We are now very, very close to actually being able to release our application to the App Store. There are just a few things left, App Store and Play Store. We have a few things left to do before we can actually do that. And one of the most important things we need to take care of are loading screens in our application. And if you remember from what we've done so far, we've been working with Bloc, we've been working with our auth service, and we've created an AuthBloc. And we also have loading state in some of our auth states. Actually, I can't call it loading state. We have loading property on some of our auth states. So when our auth block returns a state, depending on which state it is, then we can actually see whether it is loading property or not. And we've been working with loading dialogues so far. And they are just simple dialogues that we're displaying on the screen with a column, with a circular, a progress indicator, and we also have a sized box just to separate the loading indicator from a text that we're displaying on the screen. This has been working okay so far, but as I mentioned at the end of the previous chapter, we have a bit of a problem in that. If you remember from the code, actually, I can bring it on the screen so you can have a look here. Let's go to our loading dialog. Loading dialog. At the end of this, if you remember, we return a function, which in turn, upon calling which, we pop our navigator. However, as you can see, there is no transaction in here, meaning that the navigator can't necessarily know that what it is popping at the moment is in fact our loading dialog. And this problem is actually quite big in that you could, for instance, have a loading dialog on the screen, and then while that loading dialog is being displayed, you could display another screen and push that screen in your navigation stack. And then if you then try to dismiss your loading dialog, what you will dismiss, in fact, is the second screen that you displayed in the stack. So this process is not transaction-based in that you're playing literally with the navigation stack in Flutter, and that's not such a wise thing to do. So what we want to do in this chapter is to clean up our loading screens in the application and make sure that they are using overlays instead of normal dialogues. So now I named overlays, and it is a good time then to explain what overlays are and why they're good, especially for loading screens. As you know, normal screens that you display on the mobile telephone, for instance, or on the web, or on a desktop with Flutter, they're basically placed inside a navigation stack. So the navigation stack is there to keep track of which screen is displayed and then which screens you can remove from that stack. And so they have a hierarchy. However, if you want to display something on top of the navigation stack, independent of the navigation stack and the various changes that could happen to the navigation stack, you could use, and you probably actually should use, overlays, either directly or using other material components that are provided by Flutter that in turn use overlays. So overlays, as their name indicates, they have the ability to place themselves over other content that is currently displayed on the screen. And that makes them the perfect candidate for loading screens, for instance, because loading screens are usually displayed on top of the current content that the user is looking at. So in this chapter, we're going to focus on using overlays to improve the state of our loading screens in the application. So now, before we actually get started writing our loading screen, what we need to talk about is a controller. As its name indicates, a controller is an object usually that you can pass from a function to another. And using this controller, usually an object that receives that controller is able to control either the contents or the behavior of the object that is being displayed on the screen, for instance. So imagine a scenario where you have a loading screen already appearing on the mobile device and you're telling the user, wait while I'm logging you in. Now imagine that you want to kick off another process while that is ongoing, and you want to display a loading screen again to the user while the previous loading screen is already displayed on the screen. So a typical way of doing that would be, for instance, to dismiss the first loading screen, show a new loading screen with the new content, and when you get rid of the second loading screen, then you can display the first loading screen again as that process is ongoing. However, this is quite a bit of a race in that you have to know the previous context, what loading screen was displayed before, what loading screen you're displaying now, if there was a loading screen before, you have to display it again. So it's not so scalable in that you will personally then be responsible for keeping track of the state of your loading screen. So what we're going to do in this chapter is to create a loading screen that is able to be controlled, and its text and contents is going to be controlled using a controller object. So upon creating that loading screen, we're then going to get a loading screen controller. And this loading controller is going to allow us to, one, dismiss the current loading screen that is displayed on the screen, if any. And then secondly, it's going to allow us to update the contents of the loading screen. So without further ado, we could actually start by having a look at creating this loading controller or loading screen controller. And then we're going to use this loading screen controller where we create our loading screen. So as usual, I'm going to do some reshuffling on the screen. So let me make the code bigger here and then the font a little smaller. Let's then actually here, I'm pretty sure that we don't need strcpy because we're not going to have a look at how that loading screen looks like right now. We're going to write quite a bit of code and then we're going to put it into use. So I'm going to make Visual Studio Code full screen in here. And I'm going to get rid of this bottom bar here. Okay, so as the caption indicates, what we're going to do now is to go ahead and create our loading screen controller under lib helpers loading screen controller. And let's go in here and have a look at lib. And we can see we have lib utility service extensions enums constants views, but we don't have helpers. So I'm going to right click on lib and just say new file. And then I'm going to say helpers so that you can also see it here, helpers, loading, and then loading screen controller. Dart. So that's going to create the intermediate folders for us as well. So you can see now we're under lib helpers loading screen controller. Okay. So what we need here, as I mentioned before, is the ability for us to be able to control two things: to close the loading screen and also update its content. So let's go ahead and define these type def. So let's just say type def, and we're going to call it close loading screen. And this is just a Boolean function that indicates whether the loading screen could actually be closed or not. Okay, so it's just a function definition for now. There is no implementation of that function yet. So let's also go and create a type def. And we're going to say update loading screen. And this is a void function, actually a bool function, which will also indicate whether the text could be updated. And we just say text. So what we're saying in here, we will have two functions that will conform to this interface basically soon, as you'll soon see. Okay, excuse me. Let's then go ahead and create a class, and we call it loading screen indicator, or sorry, controller. And let's mark this as immutable as well. And for this, we need material. So actually foundation would do as well. So let's just go in foundation. And in here, I'm actually going to say show immutable, just like that. So we just need the immutable part of the foundation package in here. Okay, so that's the definition of our loading screen controller. So what it does is that it basically takes in a close loading screen as a parameter, and we say close, and we also say final update loading screen update, just like that. And I'm going to get help from Visual Studio Code to complete this as a constant constructor, and I'm going to make these parameters also required. So these things we've talked about so much before, so that's why I'm kind of jumping over them as fast as possible. Hot reload is not working so well right now. It's just because the application on strcpy is not on the screen, and that's why hot reload isn't working so well. So I'm going to just jump to the application, and now hot reload works. And then I'm going to put strcpy on another screen so it doesn't bother us so much. Okay, so that's our controller. So we're then going to work on creating a function that can display the loading screen, and that function itself is going to return a loading screen controller to you. So that's the beauty of that function. Using the controller, then you can close the loading screen or update it. So you can see that these two are basically functions that the call side can accept and call in order to close and update the loading screen respectively. All right, that was the loading screen controller. What we need to do now is to work on the loading screen itself. So let's go ahead, as the caption indicates, we're going to go to lib helpers loading in this folder, and we're going to create a new file inside loading, and let's just call it then loading screen dart. And inside loading screen, we're just going to create a loading screen class, okay? And we're going to make our loading screen a singleton. And since we've done singleton twice before, I'm just going to basically paste the pattern in here so we don't have to write this boring code again. But this is a pattern that we've done so far twice, as I mentioned before. So you should basically know how it works. So we have a private constructor, then we have a factory constructor, which is public, which in turn uses a static final variable, which in turn calls the private initializer. So it's just a bit of a, we could actually do it like this so this is in order basically. So when someone calls our loading screen constructor, factory constructor from outside, in turn calls this, and this in turn calls this. So it's a layer base. It's 3 layers. Okay, so what we're going to do in here, we're also going to keep hold of our loading screen controller. And so let's go ahead and say loading screen controller. As you can see, it's going to auto import it for me. So I'm just going to say loading screen controller, and let's just say it's optional because we might not actually have it. And then what we're going to do in here, we're going to have a function called show, as I can see. And then we're going to have a few more functions that are going to allow us to control basically our loading screen. And I wonder which one is actually best to work with first. It could be that we should be working, for instance, with the show overlay function. So let's go ahead and do that. So let's say that we are going to have a function on our loading screen class, and we're calling it show overlay. So, and this show overlay is then in turn going to return an instance of loading screen controller. So let's go ahead and start writing that. So loading screen controller, and we say show overlay. And this function has 2 required parameters. So I'm going to put curly bracket in here, a curly bracket in here, and let's just say we need a build context. So build context, and it's going to auto import from material. So that's great. Build context. And required parameter, build context, and I'm just going to call it context. And then upon you wanting to show an overlay, you also have to specify its text. So because what we're saying in here is that an overlay can't be displayed without an actual text in it, okay? And remember, we're using the word overlay, but in this case, our loading screen is going to have a custom overlay with some material components like a column and button, etc., etc., okay? So show overlay in this case means show the loading screen with this text, okay? So we call it that, and then let's go ahead and basically say this is a string of text, just like that, okay? And perfect. So that's fine. So now what we're going to create now is we're going to create a stream controller that will then new strings that are provided by this controller. Remember, we created this thing. So if someone updates the loading screen text, we're going to put those strings inside a stream controller. So let's go ahead and create a final, if I can spell. So we'll say this is a stream controller of string. Okay. So we just create that, and it can't find stream controller. So I'm just going to say import lib dart async. So that's another import right here, which you might have to do by hand if you don't have Visual Studio Code, or if you're not using, for instance, a text editor or IDE that can auto import things for you. Stream controller is available in Dart async. So then the first thing we're going to do is to add the current text into our stream controller. So this text parameter that was provided to us, we're going to put it inside the stream controller, okay? So what we need to do is basically use a new function that we haven't used before, which is called overlay of context. So if you look at the return of this, it will return something called an overlay state. And it says the state from the closest instance of this class that encloses the given context. So we need this state in order to be able to display our overlay. So let's just grab this overlay of context and put it inside a state like this. And then what we're going to do is since overlays are kind of displayed on top of everything else that's on the screen, they don't have intrinsic sizes as such. So if you're using, for instance, material components such as various widgets inside your Flutter application, if you create different containers, buttons, they have some sort of intrinsic size in them. However, with overlays, you kind of have to grab like the state of the current screen and what components are displayed on it, the available width, the available height. So we need some sort of a size to basically base our overlay on top of. So let's go ahead and grab our render box. And I'm going to say using this context, and we're going to get find render object like this as render box. Okay, so there's lots of documentation available about what render box is, but it is kind of like low level, and I'm not going to go into so much details about that. But let's go actually have a look a little bit here. As you can see, it's a render object, and it is quite low level, as I mentioned, inside rendering box. And what it will do, it will allow you to basically extract the available size that our overlay can have on the screen. So let's go ahead and create a final size in here and say render box dot size. Okay, so that's that. Then what we need to do, we actually need to now create our overlay. So our overlay, you may think, oh, this is the overlay because we call it overlay here. Well, it's not really, because the overlay is like the in this context, that's overlay of is the state of the parent overlay context. So what you are going to create in your application is actually called overlay entry. So when we say we're going to create an overlay, what we actually mean is an overlay entry. Okay. So let's go ahead and create an overlay entry in here. So we're going to say final overlay is overlay entry, just like that. And then we have a builder function. I'm going to get Visual Studio Code to complete this. It needs a context. All right, so let's go in here. Now, overlays, they don't have a parent like a scaffold or anything. So if you don't wrap your or like this component that you return from your builder, which should be a widget. Let's go in here. You can see it's a widget. If you don't wrap this inside some sort of a material component, such as scaffold or material itself, your overlay is going to have horrible styling because it's not going to have any default system styling. So, excuse me, what we're going to do in here, we're going to return a material component. And material is going to allow you, if you look here as a documentation of material, it says creates a piece of material. I mean, okay. But what it basically means, it is actually, let's have a look at its code. Maybe that makes more sense. So is a stateful widget. So it will create a stateful widget for you, which has some default styling. So you can put your components in there and they'll be styled according to the system skin. Okay. So let's say that we are then going to give the material, which is going to cover the entire screen. This material component that we're returning here is going to cover the entire screen, remember. So let's first paint the entire screen with kind of like a dark color. As you know, when you display like errors or dialogues to the screen, to the user, usually what they do is like they paint the background, the entire background, kind of like a dark color. So then they can display their dialogue in the middle of the screen and kind of give it kind of like, some sort of a elevation, so it pops out of the screen a little bit. So what we're going to do in here, we're going to say color. The color of our material stateful widget in here is colors black with alpha of 150. Okay, and then the child of our material then is going to be a center. Okay, so that's what we're going to create here. So let's then go in here, and what we're going to do is the child of this is going to be a container. So I'm just going to create a container here and then put a semicolon there, and it's happy now. So then our container is going to place some constraints on our overlay. So it's going to say, for instance, that its max width and height should be a certain value. So we haven't used this before, but we're going to now use something called constraints in here. And you can see the value of constraints is of type box constraints. So let's say constraints, and then we say box constraints. Okay. So we're going to start with max width. So then we're going to say size width. multiplied by 0.8. And what we're basically saying in here is saying that this dialog that we're displaying to the user is going to consume at most 80% of the available width on the screen. So this is our way of creating some margins to the right and left for those of you who are web developers and are like know about margin. And even if you're even if you're a designer, you'll probably know already about margins. So what we're saying is that this container needs to wrap itself around its contents, but if the contents grow, it's going to go at most 80% of the available width. And this width is coming from our render box, okay? So that's that. And we're going to do the same thing with max height. So we're going to say size height multiplied 0.8. And then we're going to give it a min width of size width multiplied 0.5. So we're going to say at least it should grab half of the screen width. Okay. Then let's give it some decoration. So we're going to say this is box decoration. So let's go in here. And so this is just to give it some border. So usually dialogues, or in this case, an overlay that we're displaying to the user, they have some sort of a border. So it creates this kind of like a beautiful elevation. So if this is the dark background in here, which we created with black of alpha 150, then we have our basically overlay in here, or overlay, we call it here, as you can see, overlay entry. Then the overlay entry will be placed here, but it will have some border around it to separate it from the background. Okay, so this is just a technique to separate our overlay from the background. So we're going to say the border is color white, color is white. And then we're going to say it has a border radius of border radius. All these documentations on the screen are just driving me crazy. Border radius dot circular, and let's just give it a circle value of 10 in here. Okay. Sometimes documentation is just in the way. So let's then in here, as you can see now, we have an empty container. We should never do that. So let's go in here and just create a child for it. So the child in here is going to be a padding. So, or maybe we could just say single child scroll view for now. And then I'm going to embed the single child scroll view inside padding. That's my preferred way of doing this. So just like that. And let's just give it padding of 16 for now. Okay. So the reason that the child of this padding that we created here is a single child scroll view is, as you remember, we said the max height of our overlay entry is 80% of the available height on the screen. That's all great, but what if your application is displayed on a very small screen, and then you're displaying a lot of text? Well, if you don't put your contents in the entire contents of your material widget inside a single child scroll view, then your content is going to be basically chopped. So the users are not going to see the content in its entirety. And what single child scroll view does is that it tries to not scroll its contents if the content has enough space to be displayed on the container. But if the contents overflows the container's height, for instance, then it's going to allow the user to scroll on that container. So it works perfectly. Trust me. So let's go in here and then go and inside the single child scroll view, create a child. And in here, we're going to have a column. And our main axis size is going to be main axis size of minimum. Because remember, if you don't give a main axis size of minimum to your column is going to grab as much space as it can. So it's just going to expand as much as it can. And if you say main axis size is minimum, it's just going to basically try to hug its contents as much as it can. And then we're going to say main axis alignment is main axis alignment of center. So it's also going to place its contents vertically in the center. Okay. Then what we're going to do in here in column children. So let's go in here and say children. Then let's create a sized box and give it a height of 10. So we're creating some top margin from top of the column. So this is saying that we have a column, we're going to put some stuff in it, but give it 10 points of emptiness on top. So it just creates a little bit of a margin. Okay. And look, I fully understand that this is a lot of abstract stuff. It would be a lot nicer if you could actually see this on the screen. But sometimes when you're programming, especially in Flutter, since it's so declarative, then you have to kind of use your imagination on how this thing is actually going to look like on the screen. So you could do a lot of experiments and test this for yourself, and just maybe just even do this. Don't do anything more than this. Just use a size box on the screen and just display the overlay and see how it looks like. That also works. Okay. And right after this, let's go and create our const of circular progress indicator. So that's going to be a little indicator that sits there and displays that something is loading. And then we're going to give it another size box with a height of maybe this time actually 20. And so this creates a little bit more spacing. And then what we're doing in here, we want to create a text. But that text could change because that text is placed inside the stream controller. So we're now going to use a stream builder. So let's say stream builder like this. And our stream itself is this text, right? That we created up there. So what we need to do basically is to grab the stream from the stream controller and use it inside our stream builder. And then I'm going to help from Visual Studio Code in here and say that the builder function should be like this. And if you remember, we could use a really handy getter on our snapshot that says has data. So let's say return, or sorry, we say if snapshot has data, then we're going to return a text in here. Okay. And the text basically it's the text of the text widget is going to be the snapshot's data as string. We know that it is a string. And also we are going to give it a text alignment of text align in the center. Okay. So that's that part. And let's put a comma in there as well. And also we're getting this error right now because we're not returning a widget in all the available paths inside this builder. And we have to put an else statement in here. And otherwise, we just can't return a container, as you can see in here. Okay, so since we have to return something, we could just return an empty container for now. I mean, you could also solve this in another way. For instance, say, okay, if the snapshot has data, I'm going to return a text like this, or otherwise, I'm going to return a text like an empty text like this. You could also try to do that, but right now we're just leaving it as returning a container. Okay. So that's that part. Now we created our up until this point. So if I do this and fold this that we created in here, which is our overlay, we've just created the overlay. That doesn't mean that we're displaying it. So the way to display an overlay is to use that overlay of, which created an overlay state, and say insert overlay. Okay, so this actually adds our overlay to the entire overlay state that Flutter manages on the screen. So now we've done that. So what we need to do then, upon this happening, we need to take our return statement. And that's why we're seeing a red, basically loading screen Dart file here in Visual Studio Code. Depending on your editor or ID that you're using, you may or may not see this screen as having an error. But if you scroll up in here, it basically tells you that, well, you're not returning what you said you should return. So let's go in here and create an instance of loading screen controller. Okay, and we have to take care of the close, and we have to also take care of the update. But let's take care of close first. So it's an empty function, and the only thing it should do is to have a look at our stream controller and close that. Then we go to our overlay that we just created and basically remove it from the screen. And also we just say, yeah, we return true from this. Okay. And now we're getting an error in here saying update is not provided. So let's go ahead and create update as well. And if you remember from update, what it does, it actually takes the string as a parameter in itself. So in here, the only thing we have to do is to add that to our stream controller. So I just noticed that you can't see the code. Sorry about that. So let's add that and just return true. And to be honest with you, you could just say, well, let's just not return any value in here. You could do that as well. But I've created these function signatures so that you can also indicate an error to the call site. So you may try to get rid of these. Yeah, let's go ahead and do that if you want to, but I'm just going to leave it like this in case we want to extend this functionality in the future so that we can return false if things go wrong. Okay. All right, that was the, let's say that was our show overlay function. So that's perfect. So let's then go ahead and create a function in here that we're going to call also hide. Now we have show, let's go create hide. Okay. So let's just say void hide like this. And what we're going to do in here, we're going to take our controller like this. And if it's there, we're just going to say close. Okay, remember, close, the way it was implemented, it closes the string controller for text, and it also removes the overlay and returns true. So that's gonna, if there is a controller available on the screen, then it's gonna return that. Okay, sorry, it's gonna close that. So and also we're just gonna say controller is null. All right. So, and the point for us is that to use this function internally. Remember this. This function is going to return this loading screen controller, which we are soon going to place inside this controller variable. At the moment, controller variable is always basically null. All right. All right, that's great stuff. So now we've taken care of hide. So now that we have hide, let's go and create show. So we say show, and then we need two parameters in here, two required parameters. So let's say required build context, context, and then we say required string text. Okay, so anybody calling this function has to provide these two parameters, and they're very familiar because they are the parameters needed by show overlay. Okay, so let's go in here and we say if we have a controller, if we can actually use this controller's update function in here, so like this, and we pass the text in here or false. So now you probably are like starting to see why I'm returning true from this function. And that's because, well, if you don't have a controller, then you can't update it. Okay. So this basically, what it does, it makes the code you have to write shorter, because otherwise you'd have to do like this. If controller not null, then you would have to update. But in here, we're just saying either update the controller's text or else like this. Okay, so if we could update the controller's text, we just return, because that means, well, we already have a controller on the screen, an overlay controller, so we could update its text. So show should just return right after that. It shouldn't display a new overlay. Otherwise, we basically create a new overlay using this show overlay and assign it to our controller property on top. So we say this is equal to show overlay with that context and text. All right, fantastic. So that's pretty much all we had to do for our loading screen.dart file. So we could just save this, and I'm just going to save this file as well and close it. So let's talk a little bit about our auth state. And if you remember from our auth state, for instance, here we have auth state logged out, and that has is loading property in here. But if you look at, for instance, needs verification or logged in, etc., they don't have is loading. So what if we added is loading to a higher level here to our auth state? So any auth state in our application could potentially be in the loading state as well. So that means registering could be loading, logged in could be loading, whoever wants to could have loading. And that's exactly what we're going to do now. So I'm going to go to my notes as well. So auth state. Let's go ahead and add these parameters that we have at the bottom of the screen to our auth state. Okay, so I'm going to say final. Bool is loading. And also, let's say final string loading text, something like this. And then let's just undefined class bool. Sorry about that. I just programmed so many different languages at final, and they're so different. Every language is gonna like they have their own data types, and TypeScript has their own lowercase data types, uppercase, etc. It's just a mishmash of various different types. I just wish we could get along and have like one standard for all data types, at least the primary data types in our applications. But that's just wishful thinking, maybe. I digress. Let's go ahead and add these parameters to our auth state. And let's go ahead and do this. Make these required parameters. So we say this should be provided is loading, but the loading text doesn't need to be provided. We'll always have a default. We'll say, please wait a moment, like this. And we should close this. Have I not closed this? So like that, okay? So that's adding these two parameters to our auth state, and loading text always has a default string, okay? So let's go ahead to auth state uninitialized and add is loading in here. So let's say required bool is loading. So now that we've done that, we should actually, you see, now what we're getting in here is saying that, wait, you're not calling your super because the super has this is loading parameter in here that you need to provide because it's required, but you're not doing that. So let's go ahead and actually add that parameter to ourselves as well and say is loading. And what we do in here, we just call super and we say is loading is loading as is provided to us. Okay. So that's for uninitialized. Now let's go to registering and do the same thing in there. So we're going to say for registering, we actually have exception required. So let's make this required and also make is loading required. So is loading like that. Okay. And let's call super is loading is loading like this. All right. Perfect. That's also done. And for registering, let's go to auth state logged in. At the moment, we're taking the user. And you see, I'm making these parameters required because if you don't make them required, as soon as you go to 2 parameters, 3 parameters for creating for constructing an object using its initializer, then things start to get messy because they're not named parameters otherwise. So passing 3 unnamed parameters to an initializer, to me, it's just a little bit difficult to understand. So that's why we're making them required. Okay. So let's go in here and then make this also required named parameter required, if I can spell this user. And then I'm going to say required bool is loading. All right, like that. And then let's call super is loading with is loading. All right. So that's for auth state logged in. Now we need to also think about auth state needs verification, and we're just going to take is loading in there as well. So let's go ahead and say needs verification also has a required parameter bool is loading, and we're going to do the same thing. Super is loading. So all we're doing is that we're making sure that every state has an is loading, and that is loading is passed to the super class called auth state. All right. And then we need to take care of also our auth state logged out. So, and you see at the moment we have a little problem in here, and it says don't override fields. Thank you, Dart. And that means basically is loading is already implemented on the superclass, so we could just safely remove it from here. Okay. And then we say bool is loading, actually required bool, actually like that. And also we take in a string of our loading text like this. So now that is like that, we're just going to call super and say is loading is equal to is loading, and then loading text is loading text, just like that. Okay. Oof. And then put a comma at the end of this. Perfect. All right. So that is basically saying that we may want to customize the auth state logged out's loading text because we're taking it in and then passing it up to the super, whereas the others are not allowing us at the moment to customize their loading text. So that's why we have string loading text only for auth state logged out and not for the other classes. All right. Okay. So that's that. So we've already basically taken care of this caption as well. So we've added loading text to our auth state logged out. Okay. So now we need to save this file and just go back to our AuthBloc in here. And you can see now we have a little bit of a problem in here. So let me also go to my notes so I can bring up my notes, AuthBloc. So we have our auth state uninitialized in here. And what we need to do is say when the application opens, the absolute initial state of the application should be in the loading state. So we should say is loading true. Okay. So that's that part. We've taken care of that. So what we need to do now is to take care of, as you say, update auth state logged out in AuthBloc. So let's go and find logged out. And we can have a look in here. Let's see if we have logged out anywhere. Yes. And it says add is loading true to auth state logged out while loading. So I'm going to have a look here and see if we can actually find that. So that's, for instance, here, and that's fine. And then what we're going to do in here, we're going to say loading text. And let's say, please wait while I log you in, something like this. Okay. That's auth state logged out. That's the first thing that we have to do. And let's see where else we're using auth state logged out. And sorry, here. Yes, and that's fine. That's fine. So maybe that was the only place that we actually had to update our log state, auth state logged out. I don't think we have anywhere else that auth state logged out has to be set to true, except for when we're actually logging you in. So, and I believe that we've done that now. So auth state logged out is there with is loading true there. So that's the only thing we have to do. Okay. The next thing that we have to do is to add is loading to other states in AuthBloc. So let's start from where we're getting all these errors. So we have, excuse me, auth event initialize. So I'm going to find that in my notes in here. And in these cases, when we're emitting auth state needs verification, we should just say is loading false, because you see, when we actually end up in this state, we're not loading anything. We've already done the work that we were supposed to do. So that's sufficient basically in here. So here we have the user. So now this is a required parameter, named parameter. So it has its user, and then we're going to say is loading. And in here, we're going to say false as well. So comma in here to make the code look a little bit better. And let's then go ahead in here, which is our auth event login. And we have this problem at the end, which is auth state needs verification. And when we've emitted this auth state needs verification, is loading is also false. So pretty much is loading is false almost everywhere, except for when we're actually loading something, which is, for instance, let's see, here, when we're actually logging in, for instance. Okay. So when we have the user in here, we say user is a required parameter and is loading is false as well, comma, to make it work also. And just looking up and down this file, I can see we also have a problem in auth event register. So let's go to auth event register. Excuse me. And let's just say auth needs verification is loading is false as well. And in here, we have an exception named parameter, I believe, and named required parameter. And then we say is loading is false as well. So just a comma in there to get the formatting working. And that is working as it should. So we shouldn't have any errors basically in our auth block at this point. All right. So then I'm going to close that file. So what we need to do, as the caption indicates, we need to go to our login view and remove everything that has anything to do with loading. So let's go to a login view, and in here, login view. And at the moment, you can see we have this close dialog handle, all that stuff. So we shouldn't do any of that. So now you see the point of what we've done is for our application to be able to handle the loading dialog just in one place. Loading dialog should be handled in one place in the entire application. That's what we're trying to do. We shouldn't have loading states and loading, like handling loading or any dialogues that has anything to do with loading in various views inside our application. So that's what we're trying to get to. Okay, so let's first go to this close dialog handle and remove that because we're not going to need that anymore. And then let's go in here and remove all this code inside your login view.dart file that has anything to do with loading. So now you should just have exception handling. All right. So now let's go to our main Dart file, and here, have a look at what we have. You can see at the moment we have a block builder inside the main widget of homepage in our build function. We have a block builder, but what we want is to issue some side effects when the state changes to something that has loading in it. Okay, so you see this state at the moment is auth state, but inside there, this state could have is loading set to true. So how do we handle that? Remember, block builder is not supposed to have any side effects. That's the job of the block listener. However, we need the block builder. We actually need to return something in here. We need to return different views depending on the current state, but we also need a block listener. So how do we do this? How do we fix this? Well, the solution is using a block consumer. So a block consumer, I've mentioned this before, the block consumer builds on top of a block builder and a block listener. So it allows you to do both things at the same time. So if you ever end up in a situation in your application where you want a builder, a block builder, and you want a block listener at the same time, there is where you need a block consumer. Okay. So let's go in here and say that in our main file, I'm going to go to my notes as well. And I'm just going to say, excuse me, in here, we don't have a block builder. Instead, we have a block consumer. And now we have listener in here. And let's grab hold of this. So what we're going to do in here is say if state is loading, then what we're going to say is we're going to say loading screen, and it auto imported for me. Okay. And then we're going to say show. Okay, we have the context already, and then we either take the state's loading text or we say, please wait a moment. So if the state's loading text is not available, we just use a default one in here. So if the state is not loading, we just say loading screen dot hide. All right, so that's that. So now that we've done this, this is pretty much like the last building block that we had to build inside this application for now. So I'm just going to close this main Dart file and resize the screen. Let's go ahead and bring up strcpy. And if I dare, I'm going to hot restart the application entirely because we've done so much new work. And let's go ahead in just for experiment, I'm going to go into, what is it loading? Okay, I'm just going to go into our provider in Firebase auth provider. Inside this login, if you remember from before, create user login in here like this, we could basically have a little bit of a delay. So because otherwise we may not actually see our little overlay. So I'm just going to first not do that and try to log in normally. So foobar baz, log in. Did you see our little overlay there? So I'm going to log out now and see if we can see it. Well, we didn't. But if I try to now put a little bit of a delay in here, so I'm just going to say await, future, delayed, const, duration, seconds, 3, and just hot restart the application. And then I'm going to say my normal credentials, foobar baz, and press the login button. And this is our overlay, right? And it has the ability for you to actually update its text as it's displayed on the screen. So then, yes, everything is actually working as it should. So now we have an overlay. We don't have our loading dialog anymore. So you could safely basically go and say, well, I want to get completely rid of the loading dialog. So I'm going to leave that up to you. As now that we don't need the loading dialog. So what we achieved in this chapter is actually huge because we now have a loading screen that is independent of the entire application and is in just one place. That's the goal. We don't have many different places in our application that are handling the loading dialog. Okay. So let's go ahead and make sure we're not going to lose our code, our precious code that we've written so far. So I'm going to get rid of strcpy, increase the size of the screen. And let's go as we usually do and commit and tag our code. So if you look at our logs, the previous commit was step 25. Let's add everything and say git commit step 26. And I'm going to push these changes and let's just say git tag step 26 as well. And then git push tags, if I can spell. But if you look at our logs now, so we have step 26 in here. And if I scroll a little bit, step 25 is before it. And all the tags are also available in here. You can see 25 and 26 available right there. All right. So we've done what we promised to do at the beginning of this chapter. We created a great overlay that we can reuse in the application and just show and hide only in one place. So what we need to do now is the very exciting stuff in that we're getting really close to being complete with our application. So we have login, register, verification, email verification. We have loading screens. We have sharing, delete. It's just, we have pretty much everything for application. But we still have some little bits and pieces left to make the application more useful. Because remember, when you create your application and send it to Apple and Google for review, there's actually going to be real people who sit there and interact with your application to see if they can make sense of it. So we need to clean the UI up so that it's a little bit more user friendly. And that's exactly what we're going to take care of in the next chapter. So I'll see you there.